Hi guys, welcome to the YouTube channel Maths with OG. Now this being our very first video under this channel, we'll be starting with the most basic topic in mathematics. Now your math is divided into 5 different sections. You have your number and numeration, you have your algebra, you have your geometry, you have calculus, and you have statistics. Now I'm talking about O-level mathematics. And these sections have different topics in them, in which one of the basic topic, I can't call it the basic, but it's actually one of the basic topic, is number base. So it is wise of us to start building from the lowest topic till we get to the most advanced of topics. Now, what is number base? As you can see on the board, a number base is a number of digits or combination of digits that a system of counting uses to represent numbers. So if a system of counting have 5 digits for representing numbers, we call it base 5. If a system of counting has 20 digits for representing numbers, we call it what? Base 20. And as you can see, what I know as 5 and what I know as 20 comes from the fact that we are working with what? Base 10. So you should know already that we are working with base 10. And why do we call it base 10 system? Because the number of digits we have are actually what? 10 digits. And here you have them: 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So let's count together: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So because I have 10 digits, I call this guy base 10. So you should know that in any given base, smallest digit is always what? 0, and the biggest digit is always 1 less than the base. So if I'm working with base 20, my smallest digit is 0 and my largest digit is 19. If I'm working with base 40, smallest digit is 0 and largest digit is 39. Now let's look at some important number base system. So you can use any number to represent a base system. You can have base 2, base 3, base 4, base 5, base 6, as the case may be. So why do we call these guys important number base system? Because they have application when it comes to computer. So for those of you that will be studying computer engineering, computer science, or even electrical stroke electronics engineering, you are going to do more of this when you get to higher institution. So we have our base 2, which we call binary. We have our base 8, which we call octa. We have our base 10, like I just said, is decimal. We can also call it denary. We can also call it denary number system. We have our base 12, duodecimal, and we have our base 16 as hexadecimal. So my base 2 system has only 2 numbers, 0 and 1. Base 8 has from 0 to 7. Base 10 has from 0 to 9, like I just mentioned. Now, duodecimal, hexadecimal. Now, when we are calling base, or when we are calling numbers in base, we don't usually represent 10 as 10. We don't represent 12 as 12. We don't represent 13 as 13 because we represent them as a digit, a single digit. 10 is not a single digit, neither is 12 a single digit. Now, let's assume I'm working with hexadecimal. I have my smallest digit as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I can't put 10 here because 10 is not a single digit. Now we start representing with alphabet to represent these numbers. So my 10 becomes A, my 11 becomes B, this is 12, this is 13, this is 14, and this is 15. So this is base 16. If it's base 15, I will stop in E. If I'm working with base 12, this will be 10 and this will be 11. So I will stop in B. So this is how you represent with alphabet the moment you get up to 10. Now the last thing we'll be looking at is writing numbers in expanded form. How do we write numbers in expanded form? Now you can go back to when you were being taught place value of numbers in primary school. If I'm to write 425, or if I'm to call out the place value of 425, you can boldly say that the place value of 4 in 425, you can use the way you pronounce it. It is 425. So leave the 25. 4 place value is 400. Then 25, leave the 5. 2 place value is 20. And 5 place value is 5. But how do we come about this place value? Is by representing this guy in expanded form. Now I'm working with base 10. In the expanded form, we work with powers. So I can say this guy is having a power of 0, a power of 1, and a power of 2. So in expanded form, this becomes 4 multiplied by 10 raised to the power of 2. This becomes 2 multiplied by 10 raised to the power of 1. And this is 5 multiplied by 10 raised to the power of 0. 10 raised to the power of 2 is 100. 100 times 4, 400. 10 raised to the power of 1 is 10. 10 times 2, 20. 10 raised to the power of 0 is 1. Any number raised to the power of 0 is 1, as long as that number is not 0. So I can write here, a raised to the power of 0 is always 1, as long as a is not equal to 0. So if a is equal to 0, a raised to the power of 0 cannot be 1. It will become indeterminate, meaning we cannot determine the value. 10 raised to the power of 0 is 1. 1 times 5 is 5. So this is the place value of 4, place value of 2, and place value of 5. If you add them up, it should give you back the number. But this is the number in its expanded form. Now, how do we write other base in its expanded form? So let's pick a number in base 3. This can be a number in base 3. 120. No, we don't call it 20. We'll just call it 121 base 3. So in its expanded form, this becomes 0, 1, and 2. So here we have 1 times 3 raised to the power of 2 plus 2 times 3 raised to the power of 1 plus 1 times 3 raised to the power of what? 0. So this is how we write this in its expanded form. So here we can add a plus and a plus. This is this guy in its expanded form. So in any given base, you can always write a number in its expanded form. So in our next video, we'll either be looking at how you convert from another base to base 10 or from base 10 to any other base, because our basics or our points that we are looking at is actually what? Base 10. So we are going to be working on how we can convert from another base to base 10 or from base 10 to another base. Then we can now look at how you add in other bases, multiply in other bases, subtract in other bases, and also divide in other bases. And remember, you can have fractional parts in other bases. We will also look at that. So thanks for watching this video. Please don't forget to like. Also, you can leave your comment below if there was an error in the solution, or if there's any question you would like to ask. Then please do well to subscribe. Very important. It will actually make me happy. Then lastly, share this video to your friends who you think will need this video. See you guys in my next video.